Okay, today I am going to teach you method of finding complementary function and solution of the homogeneous linear differential equation. Okay, while finding the complementary function, we use roots of the auxiliary equation. In the last class itself, I explained how to find auxiliary equation and roots. Okay. Now come to the case 1. Roots are real and distinct. Say for example m1, m2, m3. I'm taking only 3 roots. Okay. m1, m2, m3 are not equal and means different roots and real roots. Say for example 1, 2, 3, -4, -5, 2, 0, etc. Okay. If roots are real and distinct, see here. How many roots are there? 3 roots. We have to take 3 arbitrary constants, C1, C2, C3. We have M1, M2, M3 are the 3 roots. We have to take C1, C2, C3. C1 e power M1x is the first term. Second, plus C2 e power M2x plus C3 e power M3x. Okay. For example, 1, 2, 3. 1, 2, 3 are real roots and different roots. Then CF is, how many roots are there here? 1, 2, 3, 3 roots. That means you have to take how many arbitrary constants? 3 arbitrary constants. C1 e power 1x plus C2 e power 2x plus C3 e power 3x. Okay. Next up. -4, -5, 2, 0. How many roots are there? 4 roots. That means you have to take 4 arbitrary constants. C1, C2, C3, C4, etc. Okay. Now, first term CF is C1 e power -4x plus C2 e power -5x plus C3 e power 2x and plus C4 e power 0x. Okay. Next, come to case 2. Real and equal. See, M1, M2, M3 are real numbers and equal numbers means say I will take M. For example, 2, 2, 2 real root and equal. See, -4, -4, -4, -4 real root and equal. Okay. In this case, for M1, M2, M3 are equal to what? M. In this case, how many roots are there here? 3 roots. That means you have to take 3 arbitrary constants, C1, C2, C3. First term is C1. You have to take polynomial x power 0 e power mx plus C2 x power 1 e power mx plus C3 x square e power mx. If you take e power mx common and x power 0 is 1, therefore CF is C1 plus C2x plus C3 x square into e power mx. Okay. Now, come to the example. 2, 2, 2. C1. How many roots are there? 3 roots. That means you have to take 3 arbitrary constants C1, C2, C3. CF is C1 plus C2x plus C3x square into e power 2x. Next one. -4, -4, -4, -4. How many roots are there? 4 roots. That means you have to take 4 arbitrary constants. C1 plus C2x plus C3x square plus C4x cube into e power -4x. Okay. Now, I will mix both the case 1 and case 2. That means 1, 2, 3, 4, 4, 4. 1, 2, 3 are real and distinct. 4, 4, 4 are real and equal. Case 1 plus case 2. Okay. How many roots are there? 6 roots. That means you have to take 6 arbitrary constants. See, C1 e power 1x plus C2 e power 2x plus C3 e power 3x because 1, 2, 3 are real and distinct. Case 1. Next, come to the case 2. 4 is real and equal number. Now you have to take continuous arbitrary constant C1, C2, C3. Next, C4 plus C5x plus C6x square into e power 4x. Okay. We come to case 3. Roots are imaginary or complex roots. Okay. In this case, for example, alpha plus or minus I beta. Alpha is the real part, beta is the imaginary part. CF is e power alpha x real part. Exponential power is always real part into, you will get two terms in terms of cos and sine. First term, C1 cos beta x plus C2 sin beta x. Beta is the imaginary part. You have to take within the trigonometric function. For example, 1 plus or minus 3i. 1 is the real part, 3 is imaginary part. CF is e power 1x. Real part is 1 into C1. What is imaginary part here? 3. C1 cos 3x plus C2 sin 3x. Okay. Next, 0 plus or minus 2i. A real part is 0. Imaginary part is 2. CF is e power 0x. That is equal to 1. C1 cos 2x plus C2 sin 2x. Okay. Next, case 4 is distinct imaginary roots. Imaginary roots are different. Say alpha 1 plus or minus I beta 1 and alpha 2 plus or minus I beta 2. You know how to write the CF in case of imaginary? Treat this one is different one, this one is second one. Okay. Here we have two roots. Again two roots. Total 4 roots. It means we have to take 4 arbitrary constants. Write the CF for the first two roots. C1, C e power alpha 1x into C1 cos beta x, beta 1 plus C2 sin beta 1x. Now come to the second one, e power alpha 2x, C3 cos beta 2x and C4 sin beta 2x. Okay. For example, 1 plus or minus 3i, 1 plus or minus 2i. For 1 plus or minus, write the CF plus. Write the CF for the second one. That's it. Okay. But we have to take continuous arbitrary constants C1, C2, C3, C4 like that. Okay. Next, case 5. Repeated imaginary roots. Imaginary roots repeats 2 times, 3 times, etc. In that case, see, alpha plus or minus I beta repeats how many times? 2 times. Twice. That means, what is the real part? Alpha. E power alpha x into, in place of C1 and C2, take a polynomial C1 plus C2x. If it repeat 2 times, take C1 plus C2x. If it repeat 3 times, C1 plus C2x plus C3x square like that. Okay. 4 times, C1 plus C2x plus C3x square plus C4x cube like that. Okay. See, since it repeat 2 times, coefficient of cos beta x is C1 plus C2x and coefficient of sin beta x is C3 plus C4x. Okay. Now, if alpha plus or minus 3i repeat 3 times, see, e power 1x into C1 plus C2x plus C3x square into cos 3x, C4 plus C5x plus C6x square into sin 3x. Okay, this is about method of finding the complementary function. Now, I will take 1, 2, 3, 4, 4, 4, 5 plus or minus 6i, 7 plus or minus 8i, 7 plus or minus 8i, 9 plus or minus root 8. See, here 1, 2, 3 are real and distinct. 4, 4, 4 are real and equal. Plus 5 plus or minus 6i imaginary. 7 plus or minus 8i and 7 plus or minus 8i. Imaginary roots repeat how many times? 2 times. And this one is very important. 9 plus or minus root 8. You assume that 9 plus or minus root 8 is the imaginary. No imaginary unit here. See, we have I. No imaginary unit. Okay, we have only 9 plus root 8, 9 minus root 8. That means roots are real and distinct. Case 1, we have to take care in this case. Very important. Okay. Now come to the solution of the homogeneous differential equation. Homogeneous means right hand side is 0. Given differential equation is second order linear differential equation and it is homogeneous. We can write this differential equation in terms of the differential operator, d square, d etc. Take y common, then we get polynomial operator as d square minus 5d plus 6. In f of d, this is your f of d. Replace d by m and equating to 0, we get auxiliary equation. Find the roots. You know how to find the roots. Here roots are 3 and 2. 3 and 2 are real and distinct. Okay, case 1. Now write the C of C1 e power 3x plus C2 e power 2x. Pi 0 because RHS is 0. Pi 0. General solution is CF plus Pi. Write the CF and Pi 0. General solution is y is equal to CF itself, C1 e power 3x plus C2 e power 2x. Okay, now come to the second one. D square minus plus 8y plus 8 dy by dx plus 16y is equal to 0. Homogeneous, right, in terms of D. Take y common, replace d by m, roots, real and equal, case 2. C1 plus C2x into e power minus 4x. Pi is 0. Write the general solution. Okay, like this. This is your general solution. Next problem. Third order linear differential equation, and it is homogeneous. Directly it is given in terms of a differential operator. Replace d by m. Find the roots. We get 3, 2, 2. While finding the roots using calculator, it shows only 3 and 2. Okay, since degree is 3, second root repeat one more time. Very important. Already explained in the first video. Okay, here roots are real. This one is different. These two are real and equal. Case 1 plus case 2. Okay, CF C1 e power 3x plus C2 plus C3x into e power 2x. Okay, case 2. P is 0. Write the general solution. Okay, y is equal to C1 e power 3x plus C2 plus C3x into e power 2x. Okay, this bracket belongs to these two terms only. Next, third one. Next one. Again, third order differential equation. Okay, here there is no constant term. No constant term here. If you write in terms of capital D, we get d cube minus 18d square plus 81d plus 0 into y is equal to 0. This is your auxiliary equation. Roots 0 and 9. 9 is the second root. Second root repeat one more time. Very important. Second root repeat one more time. Here, what is the independent variable? T. See? D cube y by dt cube. T is independent variable. That means you have to write the solution in terms of T only, not in terms of x. Okay? CF is C1 e power 0t plus C2 plus C3t into e power 9t. Okay? Write the general solution. That's it. Next one. Y triple dash plus, minus 3y double dash plus 3y dash minus y is equal to 0. This is your auxiliary equation. Find the roots using calculator. Calculator shows only one root. 1. What is the degree? 3. 1 repeats 3 times. That's it. Okay? Because degree is 3. For, see, roots are real and equal. If roots are real and equal, C1 plus C2x plus C3x square into e power 1x. Case 2. Write the general solution and y in terms of x. Why it is x? X is independent variable. Okay, here t is independent variable. Okay, next one. See, very important. 4d power 4 minus 8d cube minus 7d square plus 11d plus 6 into y is equal to 0. What is the order? 4. If it is order 4, not possible to use calculator. In that case, we have to use synthetic division method. Okay? You know how to write the auxiliary equation. See, this is your auxiliary equation. In synthetic division method, first we have to reduce fourth order differential equation into third order. Okay? How do you reduce it? In auxiliary equation, by trial and error method, find one root. Trial and error method means put m is equal to first 1. If 1 satisfies the equation, that means we get to 0. 1 is the solution. Suppose 1 is not a root, means 1 not satisfies the equation, go to minus 1. Next, minus 1 not satisfies the equation, go to plus 2. Next, minus 2, plus 3, minus 3, etc. Within plus or minus 5, you will get one root. Okay? For this equation, we get minus 1. If you replace m by minus 1, we get 0. Okay? See, first take coefficient of m power 4, that is 4. Next m cube, next m square, next m, and then constant term. Okay? Always take 0 below the first coefficient, first value. Okay? Next, add it. 4 plus 0, 4 only. Then multiply this 4 with minus 1. Right here. Add it. Minus 12. Again multiply minus 12 with minus 1. We get plus 12. Minus 7 plus 12. That is plus 5. Next term. Multiply 5 with minus 1. We get minus 5. Add it. We get plus 6. 6 into minus 1, minus 6. See, finally, 6 minus 6 is 0. While verifying the root by trial and error method, if you get 0, in synthetic division method also, the last value is 0 only. Okay? Next, by using these 4 coefficients, 4, minus 12, 5 and 6, use calculator to find the remaining 3 roots. What are the remaining 3 roots? 2 minus 0.5 means 1 minus 1 by 2. 1.5 means 3 by 2. Okay. Now, total number of roots are 4, not 3. This one and these 3. Therefore, roots are minus 1, 2, minus half, minus 3 by 2. All are real and distinct. Case 1. How many roots are there? 4 roots. Take 4 arbitrary constants, etc. Then you know how to write the CF. Pi is 0 because given differential equation is homogeneous. Write the general solution. Next, similarly, take one more differential equation, 4th order. Write the auxiliary equation. Since it is a 4th order, by trial and error method, find the roots. Put m is equal to 1. Here m satisfies the equation. That means if you put m is equal to 1, we get 0. That means start with 1 only. Write all the 4 coefficients. Next, write 0 below the first coefficient. Add it. 4 into 1. 4 right here. Add it. We get 0. 0 into 1. 0 only. Minus 23 plus 0 is minus 23. Multiply minus 23 with 1. We get minus 23. Add it. We get minus 11. Minus 11 into 1. Minus 11 into 1 is minus 11. If you add here, we get 25. 25. That means 1 is not a root. Next, go to minus 1. Similarly, directly we can substitute in the auxiliary equation, or we can verify using synthetic division method also. Okay. Next, go to minus 1. For minus 1 also, we get non-zero quantity 9. Next, go to 2. Use synthetic division method. See, for 2 we get to 0. That means 2 is the one root. These 2 are not a roots. Okay. Next, 2 is the one root. By using these 4 constants, use calculator to find the remaining 3 roots. If you use calculator, we get next root 3 roots are 2 minus 3 by 2 and minus 3 by 2. While finding the roots in this problem, we get 2 and minus 1.5. It shows only 2 roots. Second root, repeat one more time. Okay. Next, now write the total number of roots. 2, 2, minus 3 by 2, minus 3 by 2. 2 by using synthetic division method. This one, and these 3 by using calculator. Now, first 2 roots are real and equal. Next 2 roots are also real and equal. Write the CF. C1 plus C2x e power 2x plus C3 plus C4x into e power minus 3 by 2x. Okay, write the general solution. In this case, d power 4 y minus 4 y is equal to 0. See, d power 4 minus 4 y. If you replace d by m, you get m power 4 minus 4 is equal to 0 is the auxiliary equation. But see, this is your auxiliary equation. Now, coefficients of m cube, m square and constant term is also 0. Okay? See, this can be done as like this. Here cannot constant term. See, here there is some mistake here. Leave it. Okay, come to this one. M power 4 minus 4 is equal to 0 is the auxiliary equation. This can be done as like this. M square whole square 2 square is equal to 0. This can be done as by using a square minus b square formula. A plus b into a minus b. Okay, or a minus b into a plus b. Okay, this is your first equation. Second equation, m square is equal to 2. If m square is equal to 2, m is plus or minus root 2, or roots are minus root 2 and plus root 2. Here, m square is equal to minus 2, m is plus or minus square root of minus 2, that is imaginary. Okay, roots are root 2 minus root 2 and 0 plus or minus 2i. This is your solution. Pi is 0, write the general solution. Okay. Similarly, d power 5 minus d power 4 minus d plus 1 into y is equal to 0. Same, write the auxiliary equation. Verify with 1. See, 1 for 1 we get 0, that means 1 is the root. Next term, again start with 1 only for these constants. Again we get 0, that means 1 is the one more root, that means 1 and 1 repeat 2 times. For these, see, 4 constants, use calculator. M is equal to minus 1 plus or minus I, imaginary. Okay, here how many roots are there? 5 roots. 1, 1, minus 1 plus or minus I. 1, 1, minus 1 plus or minus I. These 2 roots are real and equal. This one is a distinct root. This one is imaginary. Write the CF. Okay, here Pi is 0. Therefore, general solution is CF itself. Okay, see, general solution is CF itself. Pi is 0, general solution. Okay, now I think you got the idea about homogeneous and method of finding the complementary function. In the next class, I will explain how to solve non-homogeneous linear differential equation. Okay.